Mars, the fourth planet from the Sun in our solar system, has long held an aura of intrigue and fascination for humanity. Its reddish appearance, which earned it the moniker Red Planet, has been a subject of both scientific study and popular culture for centuries. The exploration of Mars began in earnest in the 1960s with NASA's Mariner missions, and the decades since have seen numerous spacecraft dispatched to uncover the planet's secrets. NASA's Mars exploration program aims to understand Mars's evolution, study its geology and climate, search for signs of life, and prepare for future human missions. Number 1. A 300-million-year-old wheel found in Donetsk. In a twist of intriguing cross-planetary archaeology, the first of these surprising discoveries dates back an estimated 300 million years. NASA, in an international cooperation with Ukraine, discovered a wheel-like object at a depth of 1 kilometer in a coal mine in Donetsk. This wheel was found to be strikingly similar to the wheel-like shapes observed on images of the Martian surface, captured by Mars rovers. The object, largely preserved due to coal's natural preserving attributes, was revealed to have a diameter of roughly 1 meter, with a metallic hub in the center. Its design suggested a sophisticated level of engineering, considering the age of the object. This discovery raised more questions than it provided answers. How did an object of such antiquity come to be created, and what was its purpose? The similarities between the wheel found in Donetsk and the Martian structures prompted an interplanetary investigation. Mars rovers were dispatched to the Martian sites to conduct a more detailed examination. The ensuing data confirmed the resemblance between the Donetsk wheel and those on Mars, further deepening the mystery. This discovery was a testament to the sheer power of technology, scientific collaboration, and human curiosity. The 300-million-year-old wheel found in Donetsk, reflecting a mirror image on the Martian surface, has piqued the curiosity of scientists and laymen alike. While it prompts more questions about our place in the cosmos, it also highlights the critical importance of space exploration in understanding the mysteries of our universe. Number 2. Evidence of ancient riverbeds. Another major stride in our understanding of Mars came with the discovery of ancient riverbeds, visible as meandering and branched networks on the planet's surface. These geological features, uncovered by various Mars orbiters and rovers over the years, strongly suggested that liquid water once flowed on the Martian surface, a crucial element in the search for past life on Mars. The orbiters captured high-resolution imagery of Mars's surface, revealing dried-up river channels, deltas, and alluvial fans similar to those seen on Earth. These formations indicated that Mars, billions of years ago, had a climate that could sustain flowing water, a stark contrast to its current cold, dry state. The Mars rover Curiosity made a landmark discovery in 2012 when it found rounded pebbles in an ancient stream bed in Gale Crater. The shapes and orientations of these pebbles were significant as they provided evidence of a past, vigorous flow of water. The study of these rocks and sediment layers further suggested that these ancient rivers flowed for thousands to millions of years. This discovery of ancient riverbeds holds profound implications. Flowing water is a key ingredient for life as we know it. The evidence of these riverbeds suggests that ancient Mars might have had the conditions necessary for life, presenting an exciting avenue for astrobiological studies. It paints a picture of a Mars that was once warmer, wetter, and possibly hospitable to life. Number 3. Seasonal flows of briny water. Following the evidence of ancient water on Mars, NASA's Mars Reconnaissance Orbiter, MRO, spotted intriguing seasonal changes on some Martian slopes, dark streaks known as recurring slope linii, RSL, that appear during warm seasons and fade during colder ones. This discovery, announced in 2015, pointed to the present-day flow of briny, or salty, water on Mars. The detection of hydrated salts on these slopes corroborated the hypothesis of liquid water's current existence on the Martian surface. The presence of salts lowers the freezing point of water, enabling it to stay liquid at lower temperatures and preventing it from evaporating quickly in Mars's thin atmosphere. This discovery was groundbreaking in that it moved the conversation from past water on Mars to the present. These flows, likely shallow subsurface flows, suggest a more active Mars than previously thought. Furthermore, They provide potential resources for future human exploration and potential habitats for present-day microbial life. The existence of seasonal flows of briny water on Mars is an intriguing puzzle piece in the overall Martian climate and its potential habitability. While much more needs to be understood about these seasonal changes, their discovery marks a critical step forward in our evolving understanding of the red planet and its hydrological characteristics. They represent a fascinating insight into a dynamic and continually evolving Mars, keeping the quest for the search for life on Mars very much alive. Number 4. The existence of methane. In 2004, Mars Express Orbiter first detected traces of methane in the Martian atmosphere, a discovery that was later confirmed by several missions including the Curiosity rover and the ExoMars Trace Gas Orbiter. On Earth, methane is produced mainly by biological processes, although there are geological processes known to produce it as well. This finding on Mars, therefore, has generated significant excitement. The discovery of methane is complex and perplexing. Methane on Mars is intriguing because it's short-lived. It breaks down in the presence of ultraviolet light within several hundred years. This means the methane detected must have been released relatively recently. The detection of methane on Mars has deepened the mystery of the planet's past and potential habitability. The question of whether this methane is of biological or geological origin has the potential to transform our understanding of life in the universe. Number 5. Organic molecules. In a significant breakthrough, NASA's Curiosity rover discovered complex organic molecules, the building blocks of life, on Mars in 2018. These organic molecules, which include compounds such as thiophanes, benzene, toluene, and small carbon chains like propane or butene, were found in the 3-billion-year-old mudstone in the Gale crater. This discovery doesn't prove the existence of life on Mars. However, it does suggest that the planet once had the necessary conditions to support life. Organic molecules are fundamental to our biology, and their presence on Mars indicates that the building blocks of life are present and were formed naturally on the planet. Moreover, the molecules were found in rocks from an ancient lake bed. The combination of liquid water and organic molecules gives rise to the tantalizing possibility that life could have existed there in the distant past. The discovery of organic molecules on Mars is a significant step forward in the astrobiological examination of our neighboring planet. As we delve deeper into the Martian surface and unveil its geological and chemical history, each discovery brings us a step closer to answering the fundamental question: are we alone in the universe? Number 6. Evidence of ancient lakes. In the quest to comprehend Mars's hydrological history, one of the most compelling discoveries is that of ancient lakes. The Curiosity rover's mission at Gale Crater, a 96-mile-wide depression caused by an asteroid impact, led to the finding of layered sedimentary rocks, characteristic of lake beds. Gale Crater's central mound, Mount Sharp, harbors these sedimentary layers, which reveal a cross-section of Mars's geological history. Curiosity's studies of these rocks showed that they were deposited in a lake environment, implying that Gale Crater was once filled with water. The existence of ancient lakes on Mars not only strengthens the evidence of prolonged liquid water on the planet, but also implies that the necessary conditions to sustain life were present. These findings have enriched our understanding of Mars's past, its climate evolution, and its potential to harbor life. Number 7. The Mars helicopter Ingenuity. One of the most groundbreaking achievements in Mars exploration came in 2021, not through a new scientific discovery about the planet, but through a feat of engineering, the flight of Ingenuity, the Mars helicopter. This small, autonomous rotorcraft hitched a ride to Mars with the Perseverance rover, with the aim to demonstrate powered flight in the thin Martian atmosphere. On April 19, 2021, Ingenuity made history by taking off and landing safely on Mars, marking the first instance of powered, controlled flight on another planet. This achievement was analogous to the Wright brothers' first flight on Earth, opening a new era in interplanetary exploration. While Ingenuity's primary mission was a technology demonstration, it has laid the groundwork for future aerial explorers that could further transform our exploration of Mars. This small helicopter, thus, symbolizes a huge leap forward in our extraterrestrial capabilities and the potential for new modes of exploration in the solar system. Number 8. The biggest volcano in the solar system, Olympus Mons. In the annals of space exploration, one of the most striking discoveries on Mars is Olympus Mons, the tallest volcano and largest shield volcano in the entire solar system. Named after Mount Olympus from Greek mythology, Olympus Mons was first identified as a volcanic structure by the Mariner 9 spacecraft in 1971. Standing at a towering height of approximately 13.6 miles or 22 kilometers, Olympus Mons is nearly 3 times the height of Mount Everest, Earth's tallest peak. It spans 370 miles, 600 kilometers in diameter, which is roughly equivalent to the size of the state of Arizona. One reason for the mammoth size of Olympus Mons is that the surface of Mars doesn't have tectonic plate activity like Earth does. On Earth, the movement of tectonic plates spreads the lava from a volcano over a larger area. In contrast, on Mars, a volcano erupts for a longer period at the same place, allowing Olympus Mons to grow so large. The caldera at the summit of Olympus Mons comprises 6 overlapping pits created by different volcanic events. This towering volcano is a marvel of the solar system and a testament to the geologic activity that once occurred on Mars. It provides a unique opportunity to study the volcanism outside Earth and gives us insights into Mars's geologic past. Number 9. Polar ice caps similar to Earth. Another intriguing parallel between Earth and Mars comes in the form of polar ice caps. Both Mars's poles, like Earth's, are topped with ice caps. However, while Earth's polar ice caps are made of frozen water, Mars's ice caps are a combination of water ice and dry ice, frozen carbon dioxide. The similarity of having polar ice caps on both Earth and Mars raises fascinating questions about planetary processes and climatic conditions. The study of these icy regions of Mars not only helps us understand the Martian climate better, but also allows us to draw comparisons with our home planet. Number 10. Martian soil composition. One of the key objectives of Mars missions has been to analyze the composition of Martian soil, or regolith, a complex mixture of minerals, rock, and dust covering the planet. Understanding the composition of Martian soil is fundamental to learning about the planet's geologic and climatic history, and potentially, its ability to support life. The Viking landers, Phoenix Mars lander, and the Mars rovers have all contributed to our understanding of Martian soil. They found that the Martian regolith is rich in silicon and oxygen, similar to Earth's continental crust. It also contains significant amounts of iron, magnesium, aluminum, calcium, and potassium. The study of Martian soil continues with ongoing missions, such as the Mars 2020 rover Perseverance, set to collect soil samples for future return to Earth. The ongoing investigation of Martian soil remains crucial to unraveling the red planet's past and evaluating its potential to harbor life. Number 11. An extremely thin atmosphere. Another striking difference between Earth and Mars lies in the thickness of their atmospheres. Mars has a very thin atmosphere, with a surface pressure less than 1% of Earth's. This thin atmosphere results in harsh surface conditions, with low temperatures and little protection from solar radiation. The Martian atmosphere is composed mostly of carbon dioxide, 95%, with traces of nitrogen and argon. The Mariner and Viking missions provided the first detailed data about this atmosphere, and subsequent missions have added to this understanding. One intriguing aspect of the Martian atmosphere is its loss over time. NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission, found that the solar wind, the stream of charged particles emanating from the sun, has slowly stripped away the Martian atmosphere over billions of years. This atmospheric loss likely played a key role in Mars's transition from a warmer and wetter environment in its early history to the cold, arid planet we see today. Understanding Mars's atmospheric conditions is crucial for planning future robotic and human missions to the planet. This understanding can also provide insights into the processes affecting the habitability of planets and the longevity of planetary atmospheres. Number 12. Marsquakes and seismic activity. One fascinating discovery in recent Martian exploration involves the understanding of Mars's internal activity, specifically seismic activity or Marsquakes. NASA's InSight, interior exploration using seismic investigations, geodesy, and heat transport mission, which landed on Mars in 2018, has played a significant role in this discovery. Unlike Earth, which has tectonic plates that cause most of our seismic activity, Mars doesn't have tectonic plates. But Mars does contract as it cools, causing the crust to crack and create seismic events. InSight's seismometer, SEI's, seismic experiment for interior structure, has detected hundreds of these Marsquakes since its deployment, suggesting that Mars is more tectonically active than previously thought. Understanding the seismic activity on Mars provides insights into the planet's internal structure and geologic history. It offers clues about why Earth and Mars, despite being similar in many ways, ended up so different, especially in terms of their geological activity and habitability. Number 13. Martian meteorites on Earth. A discovery that brings Mars directly to us here on Earth involves Martian meteorites. These are rocks ejected from Mars by large impacts, which then orbited the solar system before eventually falling to Earth. To date, scientists have identified over 200 meteorites that originated from Mars, based on their mineralogy and the traces of Martian atmosphere trapped within them. These meteorites provide invaluable direct samples of Mars, complementary to the data collected by Mars orbiters and rovers. They offer insights into Mars's geological history, including its volcanic activity and the presence of water. Some Martian meteorites, known as SNC meteorites, Shergottites, Knocklites, Chassagnites, have even provided evidence of past Martian life, although these findings are still a matter of ongoing debate. The discovery of Martian meteorites on Earth showcases how interconnected our solar system truly is. It also serves as a potent reminder of how violent cosmic events can send material between planets. Most importantly, these pieces of Mars provide a valuable resource for researchers studying the red planet, giving us pieces of Mars long before a sample return mission can be accomplished. Number 14. The red planet's blue sunset. While it's known as the red planet due to its rust-colored surface, a striking and somewhat counterintuitive discovery made by Mars rovers is that sunsets on Mars are blue. This surreal phenomenon was captured by the Mars rovers Spirit, Opportunity, and Curiosity, providing breathtaking images that are both beautiful and scientifically intriguing. The reason for these blue sunsets is tied to the composition and thinness of Mars's atmosphere and the scattering of light. On Earth, shorter blue and violet light wavelengths are scattered in every direction by the molecules in our atmosphere, making our sky appear blue. However, during sunset, the sun's light has to pass through a thicker slice of Earth's atmosphere, scattering away most of the blue and violet light and allowing the longer wavelength red and orange light to reach our eyes, resulting in a red sunset. The discovery of Mars's blue sunset not only enhances the planet's ethereal beauty, but also enriches our understanding of atmospheric conditions on Mars and the interplay of light, dust, and atmospheric particles. Number 15. Number of a hidden underground lake. One of the most tantalizing discoveries on Mars has been the detection of a large saltwater lake under the planet's southern polar ice cap. This discovery was made by the Mars Express mission using radar data from the Mars Advanced Radar for Subsurface and Ionosphere Sounding Instrument, MARSIS. The underground lake, discovered in 2018, is about 12 miles, 20 kilometers wide. It's situated about a mile beneath the surface and is thought to be extremely salty in order to remain liquid at cold temperatures. The presence of this lake also prompts further questions about the hydrological cycle on Mars and the form and quantity of water available on the planet. This discovery fuels the ongoing investigations to unravel the full water story of this fascinating planet. Number 16. Ancient Mars may have supported microbial life. The question of life on Mars has been a long-standing fascination for scientists and laypeople alike. The Curiosity rover, which landed in Mars's Gale crater in 2012, made a groundbreaking discovery, bringing us closer to answering this question. The rover found evidence suggesting that ancient Mars was not only habitable, but may have supported microbial life. Curiosity's primary goal was to investigate whether Mars has ever offered environmental conditions favorable for microbial life. It achieved this objective by discovering an ancient lakebed containing key chemical ingredients for life: sulfur, nitrogen, oxygen, phosphorus, and carbon, as well as clay minerals that indicate the past presence of water. Additionally, the rover detected organic molecules preserved in rocks aged about 3.5 billion years. While the presence of these organic molecules is not proof of past life, as they can also be formed by non-biological processes, they indicate that the building blocks of life were present on Mars in the ancient past. This discovery, revealing a habitable environment in Mars's past, does not confirm life on Mars, but it does add to the growing body of evidence that ancient Mars was capable of harboring life. This evidence bolsters the case for continued exploration and the search for signs of life on Mars. Number 17, radiation levels on Mars. One of the key factors influencing the potential for life on Mars and the planning of future human missions is the planet's radiation environment. Understanding this environment became possible with the Radiation Assessment Detector, RAY-D, on the Mars Science Laboratory's Curiosity rover, marking the first time that radiation levels were measured from the surface of another planet. The study of radiation on Mars is crucial as it informs the design of future missions, the planning of astronaut activities, and the necessary precautions to protect future explorers. It also provides valuable data on the conditions that any potential life, past or present, would have to endure on Mars. Number 18, the face on Mars and other geologic features. Among the most intriguing discoveries on Mars are its diverse and captivating geological features. Perhaps the most famous of these is the so-called face on Mars, an apparent hill formation in the Cydonia region that resembles a human face in certain lighting conditions. First captured by the Viking 1 orbiter in 1976, this face-like hill sparked much interest and speculation about the possibility of intelligent life on Mars. However, later high-resolution images and 3D maps from Mars Global Surveyor and Mars Reconnaissance Orbiter debunked these speculations, showing the face to be just a natural rock formation sculpted by erosion. Despite the natural origins of the face on Mars, it underscores the remarkable geologic diversity of Mars. Other fascinating geologic features on Mars include the vast Valles Marineris, a canyon system that dwarfs the Grand Canyon, and the ancient dried-up riverbeds, which provide evidence of liquid water in Mars's past. These geological features hold the key to understanding Mars's geologic history and evolution. They provide insights into the planet's past climates and potential habitability, making them the focus of ongoing study and exploration. Number 19, the Perseverance rover's core sample collection. NASA's Mars 2020 mission with the Perseverance rover has embarked on a groundbreaking endeavor to collect and cache samples of Martian rock and soil. This sample return mission is a first in the history of planetary exploration. Perseverance, equipped with a drill to collect core samples, has the mission to seek signs of ancient life and collect samples that could eventually be returned to Earth for further analysis. These samples are stored in tubes and left on the Martian surface for a future mission to retrieve and bring back to Earth. The goal of this ambitious project is to provide scientists with Martian samples untouched by the journey through space and Earth's atmosphere. These pristine samples can then be analyzed with the full power of Earth-based laboratories, offering the potential for scientific breakthroughs in our understanding of Mars's past, its potential for life, and its geology. The sample collection process is a vital part of our ongoing exploration of Mars. It paves the way for future missions and marks a significant step towards our understanding of the Red Planet. The samples collected by Perseverance could answer pivotal questions about Mars and potentially reveal whether life ever existed there. Number 20. Meteorological studies and Mars weather. Understanding the weather of Mars is crucial for both scientific understanding and future exploration. Numerous missions, including Viking, Pathfinder, Phoenix, and the Mars rovers, have contributed meteorological data to build a comprehensive picture of Mars weather. Mars experiences weather patterns and seasons much like Earth due to its tilted axis. However, the conditions are much more extreme. Temperatures can vary from a relatively comfortable 70 degrees F, 20 degrees C, to a bone-chilling minus 225 degrees Fahrenheit, 153 degrees C. Mars also experiences dust storms ranging from small whirlwinds, dust devils, to planet-wide events. These storms can last for weeks and occasionally envelop the entire planet, as observed by the Mars Reconnaissance Orbiter and experienced firsthand by the Opportunity rover in 2018. One intriguing weather-related discovery is the presence of water ice clouds similar to Earth's cirrus clouds. These clouds suggest a more dynamic water cycle on Mars than previously thought. Collecting meteorological data and studying Mars weather helps scientists understand Mars' past climate, its present state, and how it might change in the future. This knowledge is vital for